Hey you guys, in this section we're going to be talking about the law of sines. Okay, so in previous sections before, we have solved triangles. Okay, if you guys don't remember what it means to solve a triangle, it means that you solve for all three sides and you solve for all three angles. Okay, now in previous sections we've solved for triangles, but the thing that all those triangles had in common, they were all right triangles. Okay, now we're going to take that same concept of solving triangles, but we're going to apply it to triangles that are not right triangles, which means that one of the angles is not a 90-degree angle. Okay, so that means that we're still going to be solving for 6 measures, which means that we're going to be looking for the length of all 3 sides, and we're going to be looking for the measurements of all 3 angles. Okay. All right, so some of you guys have taken geometry before, but just in case you don't remember congruency, all right, we're going to go over these 3 common congruency axioms that you would have covered in geometry. Okay, so it says the following axioms from geometry allow us to prove that 2 triangles are congruent, which means that their corresponding sides and angles are equal. Okay, so the first congruency axiom that you have is a side angle side, which we abbreviate as SAS. It says if 2 sides in the included angle of one triangle are equal, respectively, to 2 sides in the included angle of a second triangle, then the triangles are congruent. The second congruency axiom that we have is an angle side angle, which we abbreviate as ASA. It says if 2 angles in the included side of one triangle are equal respectively to 2 angles in the included side of a second triangle, then the triangles are congruent. And the last congruency axiom that we have is a side, 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 which we abbreviate as SSS. It says if 3 sides of one triangle are equal, respectively to 3 sides of a second triangle, then the triangles are congruent. Okay, so we're going to be using those congruency axioms as we solve these triangles. Okay, so the triangles that we're going to be solving in this section are called oblique triangles. So any triangle that is not a right triangle is called an oblique triangle. Okay, so we're going to be using those. So the important thing, one of the things that we will lose when we are solving oblique triangles is the right to use Pythagorean theorem. Okay, so when we were solving triangles that had right angles in them, we could always use the Pythagorean theorem to find the lengths of the sides if we knew 2 of them, but that only applies when you have right triangles. So we're going to have to come up with some other methods to solve these triangles now since they're no longer right. Okay. Now, there's going to be 4 different cases that we're going to run into when we're solving oblique triangles. Case 1 and case 2. Case 1 is if we know one side and 2 angles, then we can use that to solve for the rest of the missing pieces. That's going to fall into an SAA or ASA case. Okay, remember A stands for angle and S stands for side. Case 2 will be if we know 2 sides and one angle that's not included between the 2 sides are known, which is an SSA case. In this case may lead to 0, 1, or 2 triangles, and this is also called the ambiguous case. Okay, so we're going to go over examples for cases 1 and 2. If you guys come back in later videos for case 3 and 4, we're going to apply the law of cosines, so you guys don't have to worry about case 3 and case 4 at this point in time. Okay, we're going to mainly focus on case 1 and case 2 triangles. Okay. All right, so then we're going to use the law that we're going to use to solve these triangles, and it's called the law of sines. Okay, and the law of sines says in any triangle ABC with sides A, B, and C, the following hold. So this proportion holds for all of these triangles. So we have little a over sine of A equals little b over sine of B equals little c over sine of C. Okay, now in this formula, okay, lowercase letters, so like A, B, and C, those stand for sides. Okay, so anytime you see lowercase letters, they represent sides. Anytime you see uppercase letters like A, B, and C, those stand for angles. Okay, so don't forget, lowercase letters are sides, uppercase letters are angles. So what this is telling us is that the proportion between the sides and the sine of its corresponding angle are equivalent all the way across. So side A over the sine of angle A is equivalent to side B over the sine of angle B, which is also equivalent to side C over the sine of angle C. Okay, so we're going to use that. So just pay attention that when we use this law, we're never going to use like all three proportions at the same time. Usually we will use like little a over sine A equals little b over sine b, or we may use something like this. We have little a over sine A equals little c over sine c. You're never going to use all three pieces for the same problem. You're just going to use two proportions at a time, okay? So as we go to do these problems, okay, notice that there's two versions of this law of sines. Well, two different ways we can write it. So we have this first way, which is in the top, but we also have this second way, which is in the bottom. So when you are using the law of sines, okay, whatever you are looking for needs to be in the numerator. So if you are looking for a side, the lowercase letters need to be in the numerator. If you are looking for an angle, then the uppercase letters need to be in the numerator, okay? The reason why we do that is because we don't know what the value is that we're looking for, and we don't want it to be something that's going to cause our problem to be unknown. So we wouldn't want an imaginary number to show up somewhere or a zero to show up in the denominator, because it'll cause our formula, our problem, to be undefined. So you always want to make sure whatever value you're looking for is in the numerator. So whether that be a side or an angle, that it's in the top, okay? All right, so as we are looking at the two cases that we're going to apply the law of sines to, we're either going to fall in case 1 or case 2. So we've got some suggested procedures for solving. So if our triangle falls in a side angle or an angle side angle, the first thing we're going to do is we're going to find the remaining angle using the angle sum formula, which says that all three angles in our triangle have to sum to 180. And then we're going to find the remaining sides using the law of sines. So if you have a triangle that falls in case 1, those are the steps you're going to follow. For case 2, if we have a side-side angle, this is the ambiguous case. Ambiguous means that you don't know, or there's something that's not clear. So anytime you have the ambiguous case, okay, you could end up with 0, 1, or 2 triangles. Okay, and we're going to do examples of all three of those so that you guys can see the difference. But if you end up in the ambiguous case, you're going to follow these steps. So the first thing you're going to do is you're going to use the law of sines to find the angle. 2, you're going to use the angle sum formula to find the remaining angle. And then step 3, you're going to use the law of sines to find the remaining side. And then if 2 triangles exist, you're going to repeat steps 2 through 3. Okay, so in case 2, you really need to be careful because depending on the information you've been given, you could end up with 0, 1, or 2 triangles. So the way that I remember the ambiguous case, so our textbooks are really PG-13, so they call it a side-side angle, okay? I usually remember this as this case, okay? So I ask myself, if my triangle is being this, then this is the ambiguous case. Okay, so if you have 2 sides in an angle and that angle is not included, then you need to make sure that you have either 0, 1, or 2 triangles. Okay, cool. So you come back to see the examples.